Today we're here with Javi from Idealista, and I believe Idealista, or at least your team, has been using Argilla and maybe Rubex for a long time, as far as I understand. And there have been some back and forth and some collaborations. I believe Danny did some workshops at your office or for your team. And now based on that, I actually thought it would be cool to invite you guys over. You're also located in Spain and even in Madrid. That's why I want to have you kind of tell about some cool project that we and the team have been working on about optimizing lead specification. Feel free to, take the stage.
All right, so I will share my screen right now. I don't know how this works. Yeah. All right. Yeah, can someone confirm if you can see something, please?
Yeah, I can see something.
Yeah, you can. Okay. First of all, welcome all to this session. I'm quite happy to be here today with you. I hope that you enjoyed this meetup organized by Argilla. So first of all, thanks for Argilla for letting us join the session and giving this small presentation. So a few weeks, 2 weeks ago, David told us if we wanted to join, and yeah, we decided to go just to show something that we do in the company with Argilla. So this section, it's called optimizing lead classification. I'm not gonna do a spoiler right now. I will tell you later what leads, if you don't know what leads are. So the first thing that I want to do for those who don't know what Idealista is, probably all of you who are not joining from Spain, I want to make a short introduction. So Idealista is the major real estate platform in Spain, also in Portugal, and almost in Italy too. We are just playing with another competitor, but we are almost the major port out there. So basically, a real estate platform is a place in which you go if you are interested in buying, renting any kind of property. So probably if you live in Spain or in Portugal or in Italy, I'm pretty sure that at least once you've come to our webpage, idealista.com. And yeah, you can search for any kind of property in any location in the given country. That is Spain, Portugal, or Italy. So what you are seeing right now on the screen is like the web page, the main web page. Quite simple. Simple is better, as some would say. So this is our portal. Just to give you a little more context before continuing, Idealista is a quite big company. So we are about 1,500 employees. So we are not small. It was Idealista came into the market about 24 years ago. So now, if you go to our webpage, if you try to do some kind of search, for example, let's imagine that you are searching in Madrid, the city center. This is how the listing of adverts will look like. So you would see like a listing of adverts, different pricing. You can filter by number of bedrooms, if it has a elevator, whatever. And you can also order them and see the different properties. Yeah, feel free to go to idealista.com if you want to check it. Yeah. This is not a paid sponsorship, so this is just to give you some. Going back to the topic for today, it's called optimizing lead classification. And I will try to go through this actual project that we've been doing through the previous month. I will try to tell you the story of the project from the beginning, which is problem statement, to the end, which is the training of a model. And we also, in the middle, we will go through the data extraction, auto labeling with large language models, and also how humans were useful for verifying the label. So let's begin. Imagine that, as I mentioned before, you are searching for a property in Madrid, okay? And you are interested in this property. You go, you click on the property, you will see some pictures, you will see the location, pricing, meters, the description for the advert, all that information that usually is quite useful. And you decide to contact the real estate agent who is in charge for this property. In this case, the real estate agency is called Hilmar. And you would just send them a message. So you would fill in this contact form. You write, hey, I'm interested in this apartment and I would like to make an offer for you. You fill your email, your phone number, your name, and you click on call. At that specific moment, that message is gonna be delivered to the agency just to start the conversation. And they will reply you like, hey, would you like to make a visit? And so on. The typical phase that you will go through when you are looking for a property. So here a problem arises. A contact form is a really easy way to send any kind of message. So you could imagine that through this contact form, you can send almost anything from a normal message, like the one you are seeing on the screen, to a quite different one, like inappropriate words, spam messages, offensive terms, to any kind of message, even phishing or other kind of things, to go through this contact form. You may think if Idealista is that big, you didn't have some kind of measures or rule to avoid that. Yeah, we have them, but we wanted to improve them. And that's why this project, the optimizing lead classification problem, comes into the game. So now, what is a lead? So basically, the lead contact or the lead message is the message that you are sending through this contact form. So the first message that you are sending to a real estate agency, that's the lead. And that's the thing that we are interested in controlling just to avoid these problems that I just mentioned. So now we know what a lead is, we know what the problem is, and we have to start organizing how we are going to do this. And at that point, the first thing that we have to do, as can think of, is okay, how are we going to do this? What do we need? First of all, we need to understand the problem. And at this point, we thought, okay, first of all, we will need to set some classes or categories to classify those messages or those leads that are coming in. And talking with the stakeholders and talking between us, scientists, we found out that there were four main classes for this problem. Yeah, probably there are more classes, more than four. But for a first prototype, we decided to go with these four because they were the more interesting one. And what are these classes? First of all, valid, which is messages from normal users that are showing interest in a property. For example, hey, good morning, can this apartment be rented for less? So that's like the first category and the most common one. Then we have the acquire, and these kind of messages are from usually from real estate agents that are offering their services, whether to sell or to rent the property. So usually you as owner of a property, you can go to the list and you can upload your property for free. And you don't have to pay up to $2. And usually if you are like a normal owner, these agencies are coming to your advert. They see that you are like a normal owner, and they will try to represent you in the process for renting or buying the property, just because they are getting a commission from that sale or rent. So we wanted to make this other category just to control those cases. An example, you have it on the right. Good afternoon, I'm Veronica from this agency. We are looking for properties and I would like to arrange an appointment, explain how we can help you sell your property. Third category, spam. Spam messages are those ones in which they offer you different kind of services, from taking better photographs, renovation, if you are refurbing your place, insurance, for example, if your tenant does not pay your rent, usually it's a good insurance to have, and other services that right now I cannot think of. For example, on the right, good morning, my name is Ricardo, I work at Caser Insurance Company. Our rental protection insurance first analyzes the tenant solvency to make the right decision, blah, blah, blah. So that's the third category. And the last one, and not the least important, authentic messages. And these messages are basically inappropriate word. As an example, hi, that price is outrageous, you're scammers. So that could be like an offensive message. We've seen quite a lot of offensive messages, and this is one of the nicest one that you can find on the list. All right, so this is the problem. We have to classify the incoming messages or lead in 4 different categories: valid, fire, spam, and offensive. Until now, everything is quite clear. So what next? First of all, before jumping into a new project, we always try to do like a diagram or a flow of the different steps that we want to. And in this project, we did that. We have our leads projects. We have to set the scope, was basically classify those leads in 4 categories. And now the important thing comes, data. And there are always many questions. Here are 3 questions that you have to ask yourself. Personally, I really like them. And these questions are, what data do we need? Where is that data stored? And finally, how are we gonna extract that data? Because without data, you cannot do it. So once we answer all those 3 questions, we were able to gather the data. And we went to the next step, which is label data. And this is the moment in which Argilla comes in. This big step was divided in different ones, like a manual or auto label that I will print data, the labeling tool, and the validation of data. And now that we have the data already prepared, then we could just divide in different subsets and train and validate it all. So that's it. That's like the whole flow of the project, and that's how we started this. Now, data structure. Now we are gonna begin with the different steps that I just showed you. I will try to go as much in detail as I can. And if you have any questions, you can just leave it on the chat or at the end, and I will be happy to reply. So let's begin. Data structure. One of the most important ones, because without data, you cannot do it. So what do we have here? Okay, so at Idealista, we are a quite big company and we have to store a lot of things from images to text and many other things. We have different kind of databases. For now, for this specific project, those messages or leads were stored in 2 different types of databases. One is called ClickHouse and the other one is Oracle. They are basically SQL databases that you can access quite easily. So we have that data, those messages in those databases. So through a really simple SQL extraction, we were able to gather the messages for the product. After that, those messages were not prepared. So we have to do some cleaning and pre-processing, like normalizing the text, removing duplicate, and so on. And then a big problem came into the game. So I will give you an example. Let's imagine that my name is Javi, and I'm sending a message to the property in which I'm interested. And the message would say something like, hi, my name is Javi. I am interested in your property. That's it. And then we have this other user, which she's called Sarah. And she would send something like, hi, my name is Sarah. I am interested in your property. So as you can see, both messages are quite similar, but they are not the same. So they are not duplicates. So we cannot remove them that easy. First, we thought, okay, so let's do some kind of comparison by pairs. So let's do all the combinations that are possible with pairs of 2 messages and try to remove them if they are super similar. We use kind of a similarity function from space, and that was good enough for the problem. Yeah, going back to the topic, that was not possible. We could not make combinations for all the data set that we have. Why? Because if we have in total the messages, that is 45 combinations. If we have 100 messages, That means almost 5,000 combinations. So this is a quadratic problem, okay? And if we have in total 15,000 messages, that would be more than 100 combinations. So that's a lot of time, and we didn't have that much time to process and to check the duplicates. So what was the solution? The solution was to use file search. And this is a very useful tool from Meta. And basically, it is based on vector encoding and finding similarity through those vectors. And we were able to remove almost 40% of records that were quite similar in less than 2 hours. So about 15,000 messages were removed from our dataset. Afterwards, we already have our first dataset prepared, but it was not enough. And we had to do like an additional instruction. We repeat all the process. And at the end, we end up with a dataset with 16,000 records or 16,000 messages. Okay. So that's like the dataset that we are playing with. And now, the big question. Labeling 16 examples or messages is expensive in terms of time and money. Getting a human to label all those 16,000 messages is quite expensive, okay? Do we have alternatives? About 3 years ago, we found out that large language models are quite useful. They came to the market about 3 years ago. And this year, there was just a big boom. And we are seeing that they are really useful. So we thought that by using LLMs, we could try to optimize and be much more efficient in this process. So that's what we did. And now let's see how we used large language models for doing auto labeling. So 3 years ago, a lot of LLMs came to the market from companies like OpenAI, Meta, Google Gemini, other open source like Mistral, so on. They are quite powerful. You have commercial open source version, and we decided to take all the performance that they have into our product. So this is what we do. And before coming into that flow, one question. Can we really entrust labeling decisions to large language models? And I will try to rephrase this question. Would you give a large language model the decision to press that red button that could shoot a nuclear bomb? Probably not. Probably you would like to get his advice, but you would be the one as a human to press the red button. So that's what we thought. We wanted to use LLMs to help us optimize and speed up the process, but still the final decision would be for a human. And now let's go to the flow. So this is the flow that we follow for doing auto labeling with large language models. So we have our data set, about 16,000 samples, and we also had to retain a prompt. This is like a simplified version of the prompt. I didn't want you to, it's quite big, so I just wanted to simplify it. And we ask the model, hey, what category does this example belong to? Plus, we introduce a detailed description for each class, like valid messages that come from useful people interested in a property, or offensive, inappropriate words, and so on. One for each of the 4 categories. And now, given the dataset and the prompt, we went through the large language model. In this case, it was OpenAI, GPT-4. Another question, maybe you are thinking to yourself, why did they choose GPT-4? Why not GPT-3 or even some other open source versions? And I will answer you. So we tried GPT-4, we also tried GPT-3, we tried Llama, Mistral, and other open source models out there, even Code. And we found out that for labeling purposes, GPT-4 was one of the best. we did some checks in other project, and we found out that about 90% of the records were correctly labeled by GPT-4. Meanwhile, open source models like Llama 2 and Mistral, they were getting about 75%. This was performed like 1 year ago, not 1 year ago, but maybe 6 months ago. So probably nowadays, open source model can get up to GPT-4 level. But for this project, we decided to go with GPT-4. Again, coming back, data set, prompt, GPT-4, and we get the output. So this output was JSON in JSON format, just to simplify the process. And we got 16,000 labels for the data for less than 100 USD dollars. Okay, so that's super cheap. If you're getting a human to do this labeling, probably it will cost more than $1 USD. So that's a big discount. That's why we decided to do this process. And now, humans in the loop. So the big question, is it still necessary to label by hand? This is difficult to answer, even for me after doing this problem. And I will give you the answer with the same example I gave you before. Would you give the final decision to an LLM? Would you let the model to press the red button? Right now, probably not. Maybe in 2 years or 5 years, they are that good that you can trust them. But for now, I guess that they still need our human supervision. We decided to use humans, to put humans in the loop to start that supervision of learning. And before coming into that topic, let's go with Argilla. So if you're here in this session, you probably know that Argilla is like a text labeling tool, getting quite famous. It was acquired by Hugging Face a few days ago. Congrats for that. So at Idealista, a few months ago, we decided to use Argilla for labeling text datasets. Why Argilla and not other tools? We tried other tools, that we found out that Argilla was one of the best for labeling text. First, because it is text oriented. So if you are doing a text project, go to Argilla. Don't think about that. Second, it's really friendly for users, for technical and non-technical users. And finally, it has a lot of features, like this one that you are seeing on the screen. On your left, you have the search functionality, which basically is like a normal Google engine that you search something and you will find the examples that are similar, that contains those words. And on your right, that's the similarity functionality. So if you have some record messages, some text, and when you're uploading the data set to Argilla, you also append the embeddings for all those texts, you can use this similarity functionality from Argilla, which basically gives you the ability to find all those texts or messages that are more similar to the one that you selected. So in this case, here we are selecting a message, which in English, the translation will be like, hey, I'm interested in your property. Can I make a visit? Regards. So we selected this message as like the main example, and we press the similarity function, and we can see a lot of examples with the similarity percentage on top. So this one, even though it's not the same, exactly not the same text, the context is really similar, and we can label that message as valid, as the one that was here selected. So thanks to these two tools, we started labeling at first. But then we come back with the idea of auto-labeling. And that's the point in which we introduce also the large language model auto-labels into the game. Argilla has another big feature, which is called suggestions. And suggestions allow you to upload any kind of label suggestions for a given example. Those suggestions could be from another human, from a model. You can even create them like randomness. So there are like different options to add them. In this case, we add GPT-4 suggestions, as you can see here. And this is the interface that you would see if you have the suggestions activated in your code. You would see an example that is in pending state. And for this specific example, this is still pending, you would see a suggestion, okay, with this star icon. And in this case, the suggestion for this example is acquire label, which is correct, by the way, because this message is from a real estate agency. So you would just click on the suggestion, if it's correct, of course, and click on submit. Not always these suggestions were right. So that's why I just said that humans need to go in the loop, because sometimes those labels are not correct and you just need to check them again. And now you would think, okay, but if you are doing this manual revision of labels, that's like doing the same without suggestions. Yeah, that's right. But Argilla has another feature, which is called batch labeling or batch view. Okay? But I like to call it batch labeling. And this feature allows you to see like a list of text, in this case messages, 10, 20, 50, 100 messages on one page. And if you also filter by the suggestion, that is, let's check all the messages with auto label valid. Then you would see a list of all the valid messages that GPT told us that they were valid. And through this process, we can just check them super quick. Yeah, this is valid. And just uncheck those ones that are not valid. And then just click on valid and submit all of those in one go. So this process really helped us to speed up the process a lot. So before training the model, actually we trained the model, but before going into going too much into detail about the trained model, I wanted to tell you something else that we did in this project. And I decided to call it increasing records iteratively. So what is this? So basically, imagine that you have a small data set. Let's mind that it has 10,000 examples. You train first transformers model, something very simple. And then you use that model to increase the amount of examples that you have on your dataset. So Idealista receives every day thousands of leads. So we have enough of input data. So if we have already a trained model and also we have new records, we can do the inference with those new messages. We are going to get some statistics and probabilities for each class. And by extracting other metrics, we can then load all that info back again Gila, and we can continue labeling. And what is interesting about this way of doing this? First of all, you are increasing the number of records quite quickly. And second, you don't depend now on a large language model to do the auto labeling. We already did that on the first iteration, but now that we already had like a good enough model, we could use that transformers model to keep adding record to our dataset. And yeah, this is like a screenshot of Argilla using this like numerical metrics or filters that I just showed you, like the entropy or the margin. And also here, this 1.0 is the probability from the model, basically, to this message to be from acquired class. So this was also really helpful to basically verify or validate the model and also to increase the size of the dataset. So by increasing the dataset size, we can iteratively train models, maybe one per month, two, and we are always not losing information with new messages that might come. And now, even though I did some spoiler to you about training the model, I will show you what we did. So we fine-tuned Transformers model. And again, this is the flow that we followed. So given the data set and the choose of data sets like a train and a test or validation data set, we train a model. But the most important thing for this slide is not that we train a model. The most important thing for this slide is that we refuse to use large language models for this text classification problem. And yeah, there are two main reasons for that. First of all, we think, this is my personal opinion, we believe that large language models are overkill for simple tasks. Yeah, some of you would say, yeah, but you have quantitation and out there are really small models, 2 billion parameters and so on. But still, they are quite big, okay, quite big. And the inference time for a transformer model in a CPU is quite low in this case. So we decided not to go with large language model. And also, there is another factor. Large language models, at least those that do not have a classification head, they don't give you a confidence score, like the probabilities for an example to be part of the different classes. And that was also really important. Why? Because if a model gives you an 80% or 80% of probability for this message to be valid, then you're pretty sure that it's valid. But if the message is like, if the model is like 40% sure, then you might want the quality department team, which is the one checking those messages manually, you might want them to check that message just to avoid the problem. And that's why we refuse using large language models. After refusing large language models, we decided to go with transformers architectures. You can find a lot of them with Hugging Face, from Distilbirds to Birds, Roberta, and many others. And in this project, we tried different ones, and the best metrics were extracted by Roberta. Okay. This is the metrics, plus 90% accuracy for Spanish language, which is pretty good. This is the confusion matrix on your left. You might see the dataset is quite unbalanced. Yeah, that's right. But still, it was really difficult for us to balance the dataset because, as you can imagine, most of the messages that are incoming to the platform, they are valid. So it's not that easy to find those spam, quiet, or offensive. But still, the performance in the model is quite good, even though the balance was not that. The dataset was not that bad. And conclusions for this session. First of all, Argilla has been one of the best discoveries for this year. It has helped us as data scientists label quite easily and faster than before. Before you could go in Excel or other tools that are not machine-able, but Argilla goes a little farther and helps you to build things much more faster. And no, I'm not paid by Argilla for saying so. This is true. And we really enjoy using Argilla. It is true, I'm gonna lie, the uploading the data sets, configuration for the data sets and so on, the SDK is sometimes it's a little difficult, but I know that they are working hard on that part, and I'm pretty sure that they will make it as easy as possible. Also, and not less important, is that Argilla is really good and adapts to many different kind of projects. So if you have a text classification, we already saw with this project that it works really well. If you are working with large language models and you want to change the output of the model, that also really good. If you want to run between different replies or answers, you can also do that. You can even upload objects like images, videos, recordings, so on. that seems really good that we will be researching in the near future. So basically, Argilla gives you the tool for everything that you need regarding labeling. So yeah, to sum up, thanks to Argilla, mm, we were able to improve the lead categorization. And we were able to reduce the amount of time that the quality department team had to spend on checking the messages, the leads. So this project went through the different phases like data extraction, auto labeling, human intervention, and also we end up with a fine-tune model from Transformers architecture. And three final conclusions. They are personal, but they are also my advice, my personal advice. If you are a data scientist or you are working with data, don't forget that data is the magic behind a good model. If the data that you are using is not good enough, if the data that you are using is not well validated, a lot of problems are gonna arise. And that's probably gonna get you into a lot of trouble in the future, because if you're debugging the model and you really don't know why the model is performing good, 80% of the times the problem is because of data. So make sure that the data is good if you really want to avoid those problems. The second point is, hey, standardize your labeling process and tools. Yeah, you can use traditional tools like Excel or a simple notepad. But if you get into the flow of using like a professional labeling tool like Agila, there are many more out there. Just use any tool that you can, because they are gonna help you to optimize and speed up the process. And also in the future, if a new version comes into the project, it's very much easier for them to get the onboarding into that project through Argilla or other labeling tool, rather than checking an Excel file without my recommendation. And finally, accurate labeling facilitate analysis and decision making. Why? Because if your data is good, then you're going to be able to validate the model and you're going to be able to iterate much more faster. That is, if you need to solve your result to stakeholders, it is going to be much better because they are going to be able to decide whether the project can go into production if your validation data and metrics are good enough, basically to support the evidence and the model. And yeah, that's all. That's all the session. This is everything from my side. I hope that you got something useful from this session, from the auto labeling to any other kind of thing. And yeah, I will just pass the word back to David or to any person in this room in case you have any questions. So thank you very much.
Yeah, cool. Thanks. I really liked the presentation. And also me and Louis also liked the fact that you also use these auxiliary metrics outcome from the predictions from the inference to actually do some better filtering than just based on probabilities and these kind of things. So it's cool to see that, because I think I've never seen anyone do that before. And there were also some questions. So one of the questions that got repeated twice was, did you do like some language detection somewhere, or did you just go with multi or cross-lingual models and then assume that everything would be optimized for not only Spanish, but also for other languages where you operate?
Yeah, if I understand correctly, they're asking whether we use like English language models or multilingual. That's the question.
Yeah, and if you trained different models for different languages.
Okay, that's a good one. So yeah, thanks for the question. Yeah, at first we tried the simple Distilbert model, which is like an English trained model, and we were getting really good results out of it for Spanish language. Okay, that's important. Then we decided to go with a multilingual model. We thought, yeah, if we are training a Spanish dataset with a multilingual model, for sure, that's going to be much better in terms of performance. But no, we were wrong. And I was actually not that surprised because I already knew that some English models were outperforming multilingual models in specific languages. So yeah, the answer for this question is yeah, we finally use English models trained with Spanish, Portuguese, or Italian datasets. And the second question, do we have different models for each country? We try both ways. So at first, we try to have one model for the three countries, like for the three languages. But at the end, we found out that it's much better to have one model per language. And as we are using transformers and they are quite, in terms of architecture, they are not that big, having one model per language is good enough for us. So that's it.
Thanks. I think that's clear how you are dealing with that. And then for rerouting, you use probably some language classification or these kind of things.
Also, yeah, want to give, you just mentioned before, it was like a nice idea to upload those metrics, those insights, entropy, and so on. That was a big, really interesting one idea from Peladio. So all the credits to him. And that was really useful for us, just to make sure that the model was good. And yeah, basically, Argilla gives you the possibility to do everything, almost everything that you want. So this like prompting engineering. So you have to find new ways to use Argilla, like to hack Argilla. I would say.
Yeah, some creative ways. Yeah, that's also from what I like. Come across a lot of new things. Then for like the initial phases of the project, how do you decide from going for like these four specific labels? Were they set or fixed at the beginning, or were they iteratively decided on? And how important was this for the remainder of the flow, in your opinion?
All right. So this is also a really interesting one. Yeah, I can say that I didn't give you all the truth. And you may wonder why. Because at the beginning, we didn't have four, we had five labels. We have one more. These labels were defined by basically stakeholders, project managers, talking with them, checking the quality department needs. And that fifth label that you are not seeing on the project was the fraud label. And you may wonder, why not the fraud label? Why is it not there? Right? It's quite easy to detect phishing examples or other kind of fraud. That's not easy. And the reason is in this project, we are analyzing like the first message for the conversation. We are not analyzing the whole conversation. So if in the first message, you are sending something really simple, hello, I am interested in your property, then it's not that easy to find fraud on that first message. So we didn't have enough holes on the data set. And that's why we decided to remove that label. And that's why we have four labels. So yeah, you got me.
Good. Happy football is always easier to talk about. And then on top of that, do you see following up this project maybe with some hierarchical classification or additional classification label? For example, I can assume that whenever something is a lead, it might be interesting for to extract some, I don't know, additional labels or maybe some time frame in which they want to combine for like viewing thing or these kind of things.
For now, those four labels are good enough for the needs and the requirements of the quality department team, who is the one using them. Maybe in the future, we decide to add some kind of sub labels. But for now, we are just focused on keep training and keep improving the model. Basically, increase the data set, train the model again, and keep going. And the main reason for this is like the most important point, because our data set is not balanced. So we need to keep improving and keep increasing the data set just to try to make it as balanced as possible. So actually, that's like the main goal and objective that we are going through now.
Okay. And what I was wondering is how many requests are you getting in like per day, per month? How often do you have one of data labeled or to be trained?
Right now, I cannot give you the number of messages that we are getting every day because I don't know. I don't know the number. Probably maybe 10,000, maybe it's more, less. I don't know. Pelayo, if you are there and you want to contribute, open to that. But I'm not really sure about the number, but 10,000 of requests or messages per day for sure. And you asked me another thing.
Yeah. How often do you consider
Train.
the models?
Probably, yeah, we are considering doing this every month, because doing that weekly could be done weekly, but the gain that you would get is not that easy because we still haven't automated the process for getting the lab, the data set, training, and so on. So we are doing this manually. So once a month is not a really demanding task. So we are doing that every month.
Okay. And for the pipeline, I can maybe imagine that sometimes people tend to, I don't know, share personal information or these kind of things within the messages. Do you do some anonymization or pseudonymization, these kind of steps as well before you actually run inference? So maybe to avoid, I don't know, potential bias and
Yeah, that's really important to do basically for these privacy things that are out there. Yeah, I think last year we got this ISO person in the team. So we have to be really careful with that. And we try as much as possible to hide and to remove all those phone numbers, name, and all that personal information that could be on the message, just to avoid any problem. Yeah.
okay, cool. Yeah, I've used Microsoft Presidio myself before. I like the project. Maybe I'm not sure what you're using.
I will check about that. That's good. Thank you for the advice.
And for the initial deduplication of the data set, did you also use like basic heuristic like rules or these kind of things, or just FICE, the deduplication?
I didn't get you. Sorry.
Or the deduplication of the records and loading,
Oh.
let's say, for the filtering or however you might want to call it. Did you use just FICE, or did you also consider using that basic heuristics? Maybe, okay, if the message is empty or if there's like certain word presence or these kind of things.
Before going with a search, we did some processing and cleaning just to remove all those like empty messages or duplicates. But then we just went through with five search, no heuristics. So we basically decided to go with five search because it was quite easy to use and it helped us to speed up the process a lot.
Cool. Yeah, I think also being used for some feed processing of data sets or like embedding similarity approaches. And there was one final question from Louis last that I think he will rewrite probably. You mentioned benchmarking LLMs for text classification and kind of converging to apparently a human alignment or like GPT-4. If you looked into using like smaller text classification models as well, maybe something like SetFit or I don't know, like they're very small, iteratively easy to train models with only a couple of
Yeah, we tried for a different project SendFit, and unfortunately, it was not giving good result for us. One of the ideas that we had was create or to fine-tune some kind of a small LLM just to help us speed up the auto-labeling process. But again, GPT-4 was getting us good enough results. So we had this other project in which was focused on researching auto-labeling. And yeah, as I told during the session, GPT-4 was about 90%, Claude was also about 90%, and there was one more. But yeah, GPT-4 and Claude were really good for auto-labeling. And the open source ones, Mistral, OpenOrchid, try the Gemma, they were good. If you fine tune them, probably they will get as good or even better than the commercial ones. But sometimes it's required in business to go fast and quick. That's basically why we decided to go with GPT-4 because it's already like an API code and it's like simple enough to use and to get going.
Cool. Then that's clear. Okay, then I would like to thank you because I know questions left. And yeah, if you ever want to combine with a new project or showcase or have questions or these kind of things, feel free to kind of ping us or we might ping you as well. I really like the presentation, especially also the part with the auxiliary metrics. And what you mentioned about us working on the SDK, maybe for everyone still here, we are actually releasing like the 2.0 version of the SDK tonight. It's a release candidate where you can actually try out and test and all of the feedback is welcome for these kind of things as well. And we hope to be able to process there. Looking forward to receiving your feedback as well and hopefully seeing you guys again. But thanks for the presentation.
Yeah, thank you. Thank you, David. Thank you all. And yeah, let's see you soon here, maybe again.
Yeah, cool. See you in a couple of weeks.
All right. Bye.